Your OAuth tokens and client secrets shouldn't just sit unprotected in plain text storage, especially in production. You'll see how to wrap a Redis-backed storage system with end-to-end encryption, ensuring sensitive OAuth credentials and tokens stay secure at rest while remaining fully functional for FastMCP's OIDC Proxy. We'll use Fernet encryption to lock down the data before it even hits Redis.
From key value, AO stores, Redis import Redis store. From key value, AO, wrappers, encryption import Fernet encryption wrapper. From cryptography, Fernet import Fernet. Import OAuth. OAuth equals OIDC Proxy. JWT signing key equals OS. Environ, JWT signing key. Client storage equals Fernet encryption wrapper. Key value equals Redis store. Host equals Redis. Example, com, port equals 6379. Fernet equals Fernet. OS, environ storage encryption key.
This demonstrates the secure credential storage pattern combined with environment-driven configuration for production-grade authentication systems. The code shows how to externalize sensitive credentials and encryption keys while maintaining a clean separation between configuration and runtime behavior. What makes this distinctive is the layered approach to security, where encryption, storage, and key management are handled by dedicated components rather than being embedded in application logic. The pattern works by composing specialized components. A Redis-backed key-value store handles persistence, a Fernet encryption wrapper manages at-rest security, and environment variables provide runtime configuration. This modular design allows each component to focus on its core responsibility: storage, encryption, and configuration without tight coupling. The OIDC proxy itself remains agnostic to the underlying storage mechanism, making it possible to swap backends or encryption schemes without modifying authentication logic. This approach solves critical production challenges: credential security, configuration flexibility, and operational resilience. By externalizing secrets and using encrypted storage, you eliminate hard-coded credentials while ensuring tokens remain protected even if the database is compromised. The environment-driven setup enables seamless transitions between development, staging, and production without code changes. The trade-off is added infrastructure complexity, but the security and maintainability benefits make it essential for any system handling real user authentication. Let's break it down line by line.
From key value, AO stores, Redis import Redis store.
Imports Redis store and a sync-compatible key-value store implementation for Redis. Handles persistent storage with automatic connection management, critical for distributed systems like this authentication service.
From key value, AO, wrappers, encryption import Fernet encryption wrapper.
This imports Fernet encryption wrapper, a transparent encryption layer that automatically encrypts all data before storage and decrypts on retrieval. It wraps any key-value store to enforce encryption at rest, eliminating the risk of exposing sensitive client data in plain text. The pattern follows the decorator wrapper design for clean separation of concerns.
From cryptography, Fernet import Fernet.
Imports Fernet from the cryptography library, a symmetric encryption implementation for secure data encryption. This provides the cryptographic primitives needed to encrypt sensitive client storage data before it reaches Redis, ensuring confidentiality even if the storage layer is compromised.
Import OAuth.
Imports Python's OAuth module for environment variable access. This enables secure configuration by reading sensitive keys from the environment rather than hard-coding them. Critical for production security, where secrets must never be in source control.
OAuth equals OIDC Proxy.
instantiates the OIDC Proxy Authentication handler. This centralizes OpenID Connect authentication logic, handling JWT validation and secure client session management for the application. The ellipsis here indicates omitted positional or keyword arguments in the OIDC proxy instantiation. It's a placeholder showing that additional configuration parameters exist, but aren't relevant to the current encryption and storage setup being demonstrated. This pattern keeps examples focused on key concepts, while acknowledging real-world implementations require more parameters.
JWT signing key equals OS. Environ JWT signing key.
This sets the JWT signing key from environment variables, ensuring secure token generation. Environment variables prevent hard-coding secrets in source code, while JWT signing verifies token integrity and prevents tampering.
Client storage equals Fernet encryption wrapper.
This applies transparent encryption to client storage using the Fernet wrapper pattern. It ensures sensitive data remains encrypted at rest in Redis, while the wrapper automatically handles encryption decryption during normal operations. The pattern separates encryption concerns from storage logic, keeping the codebase clean.
Key value equals Redis store. Host equals Redis. Example, com, port equals 6379.
This instantiates a Redis store as the key value backend, connecting to Redis at Redis. Example, com on port 6379. It provides persistent storage for the encrypted client data, ensuring session state survives between requests. The host port parameters follow standard Redis connection configuration.
Fernet equals Fernet. OS, environ storage encryption key.
This initializes symmetric encryption using Fernet, a cryptographic implementation that handles secure data encryption and decryption. The encryption key is loaded from environment variables, ensuring sensitive credentials never appear in code or version control. This pattern prevents hard-coded secrets while enabling secure storage of client data in Redis. This closing parenthesis terminates the OIDC proxy instantiation, finalizing the configuration with the encrypted Redis storage and JWT signing key. It's the standard Python syntax for ending a multi-line constructor call, ensuring all parameters are properly passed before object creation. Closing parenthesis terminates the OIDC proxy instantiation. This finalizes the configuration with encrypted Redis storage and JWT signing, completing the authentication handler setup. Secure storage patterns. The Fernet encryption wrapper combines Redis persistence with symmetric encryption, ensuring OAuth tokens survive restarts while remaining confidential at rest. Environment variables must be set before instantiating the wrapper, or you'll face missing key errors at runtime. This pattern scales from local development to distributed systems without changing the core authentication flow.
The key that encrypts everything must itself remain invisible.